Hey everyone, and welcome back for another deep dive. Today we're going to be tackling something that's been generating a lot of buzz in the energy world. Small modular reactors, or SMRs. I've been looking over some excerpts from a document called Small Modular Reactors, SMRs, an industry overview with focus on Centrus Energy and NuScale Power. And I got to say, I'm already pretty fascinated by all this. So to help us unpack all of this, we have with us an expert who, well, pretty much eats, sleeps, and breathes nuclear energy. So I guess let's get this reactor running. A lot of people, I think, when they hear the word nuclear, they immediately think of these massive cooling towers and like Chernobyl-type situations. But SMRs seem to be a whole different animal. So what's the deal here?
Yeah, you're right on. They're not your grandpa's nuclear reactors. The name itself kind of gives it away. Small being the key word here. So, whereas traditional nuclear plants are these behemoths cranking out, 1,000 megawatts of electricity or more, SMRs, they top out around 300 megawatts. And that might sound like a kind of minor difference, but it actually changes the whole game in terms of, how they're built, how safe they are, and really where they can be deployed.
So it's kind of like the difference between building a skyscraper versus like a modular home. You get the benefits of the final product, but the process is totally different. That actually makes a lot of sense.
Exactly. And it's not even just about like downsizing. The real game changer here is the modular part. Think of it like Legos, but for nuclear reactors. Instead of like, constructing this giant reactor on site, SMRs, they're built in factories, these prefabricated modules that can be shipped and then assembled on location. That has some pretty major implications, wouldn't you say?
Absolutely. When you can build something in a controlled environment like a factory, you can exert much more control over quality and consistency. Plus, it speeds up that construction time, which, as anyone who's ever done like a home renovation knows, can be a real headache.
Right, and those construction delays, they often translate to ballooning costs. And
Right.
and SMRs, they have the potential to address both of those issues. But there's another aspect of this modularity that really fascinates me, and that's the potential for enhanced safety.
Oh, interesting. I'm all ears. Tell me more about this enhanced safety thing.
So many SMR designs, like the one by NuScale, they actually incorporate something called passive safety systems. And these systems, they rely on natural forces like gravity and convection for cooling, rather than needing external power sources or pumps. So if something goes wrong, these passive systems, they just kick in automatically, without the need for any human intervention.
Wow. So even in a worst case scenario, the design itself helps to kind of prevent a meltdown. It's like having like a built-in backup generator
Yeah.
that never fails. But even with all of these advantages, I'm guessing that SMRs aren't without their challenges. So what are some of the hurdles that they face?
Well, for starters, there's still a relatively new technology, which means we're still kind of figuring things out as we go. And the regulatory landscape, it's still evolving. You see those existing frameworks that were designed for those massive traditional plants. They might not perfectly fit the unique nature of SMRs. And this can lead to uncertainty and potential licensing delays, which can drive up costs and slow down deployment.
Yeah, that's a point that probably doesn't get enough attention. Even the most brilliant idea can get bogged down in bureaucracy. So what other challenges kind of stand out to you?
Well, then there's the matter of public perception. We can't ignore that. The shadow of past nuclear accidents like Chernobyl and Fukushima, that still looms large in a lot of people's minds. I mean, it makes sense. You're talking about nuclear energy and fluke beds. It's inherently something that people are going to be cautious about.
It's like trying to launch a revolutionary new car that runs on, I don't know, banana peels, let's say.
Yeah.
But people are still traumatized by like the Hindenburg disaster. It's going to take some serious convincing to get people on board.
Exactly. Clear communication, transparency, and community engagement. Those are absolutely crucial to address those concerns and build trust. And of course, there's the economic side of the equation. While modularity offers these cost advantages in theory, the reality is that achieving those economies of scale, it requires this robust supply chain and a strong market demand, not to mention the fact that the cost of renewable energy sources like solar and wind, that's rapidly declining. So the competition is fierce.
Yeah, it's like trying to sell the world's best ice cream. But the price of popsicles keeps dropping every day.
Yeah.
But even with all of those challenges, there's clearly a lot of excitement and investment pouring into the SMR space. And our source material actually focuses on two major players, Centrus Energy and NuScale Power. So let's start with Centrus. What's their story?
So Centrus, they have this incredibly deep history intertwined with the U.S. government's uranium enrichment activities. I mean, we're talking a story that goes all the way back to the Manhattan Project. in the 1940s.
Mhm.
These days, they're known for supplying low-enriched uranium or LEU fuel components and providing all sorts of technical solutions to the nuclear industry.
Wow, so they've pretty much seen it all when it comes to nuclear energy. So what role are they playing in this whole SMR game?
Yeah, they're not just resting on their laurels, that's for sure. They're actually deeply involved in supporting the development of SMRs, particularly by producing high-assay low-enriched uranium.
Or HELEU?
HALEU, okay, that sounds pretty intense. What's so special about this HALEU stuff? It's this next-generation fuel that's crucial for a lot of these advanced SMR designs. And get this, Centrus just made history by becoming the first U.S.-owned enrichment plant to start producing HLEU in 70 years.
70 years. That's a pretty big deal. So it seems like they're really positioning themselves to be a key player in that SMR fuel supply chain.
Absolutely. Now let's shift gears and talk about NuScale Power. So unlike Centrus, who's focused on the fuel side, NuScale is all about building the reactors themselves.
Okay, so they're the ones actually putting those Lego blocks together, so to speak. So what makes their SMR design unique?
Well, their SMR is incredibly innovative. It's compact, it's designed to be housed underground, and it's heavily reliant on those passive safety systems that we were talking about earlier. Natural circulation gravity doing the heavy lifting. It's this whole new approach to reactor design that's catching a lot of attention.
Yeah, and I read that they actually achieved a major milestone recently. Their SMR was the first to receive design certification from the Nuclear Regulatory Commission, the NRC. That's not just a pat on the back, is it?
No, that's a huge deal. It basically means that their design meets those rigorous safety and regulatory standards required for operation in the United States. But as with any groundbreaking technology, NuScale's journey hasn't been without its bumps in the road. They've also faced some setbacks, including cost escalations and even project terminations.
Ah, so it sounds like a real roller coaster ride. Soaring highs and some disappointing lows.
Yeah.
So we have Centrus focusing on fueling the future of SMRs, and NuScale striving to build that future, both playing these critical roles in the advancement of this technology.
Yeah, it's this intricate dance between the fuel suppliers and the reactor developers. They're both essential for SMRs to succeed.
So what we're seeing here is this real evolution of nuclear technology,
Yeah.
driven by these advancements in SMR design and fueled by companies like Centrus. But it's all about more than just building reactors, right? It's about how this technology fits into this bigger picture of clean energy and the challenges that we're facing.
You're absolutely right. The potential of SMRs goes far beyond just generating electricity. It's about tackling climate change, ensuring energy security, and addressing some of the most pressing issues that are facing our world today.
Okay, I'm officially on the edge of my seat, so let's dive into that in part 2.
Welcome back to our deep dive into the world of small modular reactors. Before the break, we were talking about Centrus and NuScale and how they're both kind of playing these crucial roles in the SMR arena. It really paints a picture of how this technology is evolving.
Yeah, it's like watching this high-tech ballet with the fuel suppliers and the reactor developers all kind of moving in sync. But you hinted that the potential of SMRs goes far beyond just generating electricity.
Right. What's fascinating here is the versatility of SMRs, their compact size and flexible deployment. That opens up a whole new world of possibilities. Take desalination, for instance.
Desalination, okay.
Yeah.
You're going to have to remind me what that is again.
Basically, it's the process of turning salt water into fresh water. And it's a big deal, especially in regions that are facing water scarcity.
Oh, right. I remember reading about how some countries in the Middle East are investing heavily in desalination plants. But how do SMRs fit into the picture?
Well, desalination requires a lot of energy. And right now, many desalination plants are powered by fossil fuels, which, as we know, is problematic from a climate perspective. SMRs could provide a clean and reliable source of energy for those plants, significantly reducing their carbon footprint.
So instead of contributing to the problem, SMRs could actually be part of the solution to water scarcity. That's pretty mind-blowing.
And there's more. SMRs also have the potential to play a key role in hydrogen production.
Hydrogen. Now, that's a word I've been hearing a lot lately. Everyone seems to be talking about it as like the fuel of the future. What's the connection to SMRs?
Well, hydrogen can be used as a clean fuel, but producing it efficiently often requires these really high temperatures, which SMRs can readily provide.
So we're talking about a technology that could potentially address both our energy and water needs, while also contributing to the development of a clean fuel source. It sounds almost too good to be true.
It's certainly a compelling vision, isn't it? And if we connect this to the bigger picture, SMRs could be a key driver in creating a more sustainable and resilient future.
A future where remote communities have access to clean water and reliable energy, where industries can operate with a smaller carbon footprint, and where we're less reliant on fossil fuels.
You're getting it. That's precisely the kind of future that SMRs could help us build.
Okay, I'm sold on the potential, but I'd be remiss if I didn't ask about the potential downsides. And what are some of the risks or concerns associated with SMRs that we need to be mindful of?
Yeah, that's an important question, and it's one we should always be asking when it comes to any new technology, especially in the realm of nuclear energy. Safety is, of course, paramount. And while SMRs are designed with multiple layers of safety features and those passive systems that we talked about earlier, accidents can still happen. It's crucial to have those rigorous safety protocols and emergency preparedness plans in place.
You're right. It's essential to acknowledge that no technology is entirely risk-free. And when it comes to nuclear energy, even a small-scale accident could have significant consequences.
Exactly. We also need to be mindful of security. SMRs, like any nuclear facility,
Yeah.
could be potential targets for terrorism or sabotage.
So robust security measures, both physical and cyber, they need to be built into these systems from the ground up.
Absolutely. And then there's the issue of waste. While SMRs might generate less waste than traditional reactors, we still need to deal with the safe handling, storage, and disposal of radioactive materials.
Right. That's a challenge the entire nuclear industry has been grappling with for decades. It sounds like a lot to consider. And a lot of responsibility for the companies and governments involved.
It is, but I think it's important to remember that these challenges are not insurmountable. The nuclear industry has this long history of innovation and problem solving. And as SMRs continue to develop, I'm confident we'll see even more advancements in safety, security, and waste management.
That's reassuring to hear. Okay, let's shift gears a bit and talk about the economics of SMRs. Our source material mentioned costs being a potential barrier, but also hinted at some exciting opportunities for growth. How do you see those two sides of the coin playing out?
Yeah, it's definitely a balancing act right now. On the one hand, those initial costs of building an SMR are still significant, especially for those first-of-a-kind projects. It's like with any new technology, those early adopters often pay a premium.
Right, it's the price of being on the cutting edge. But the real promise of SMRs lies in their modularity, right? The idea that as we move towards mass production, those costs will come down.
Exactly. The hope is that as the technology matures, and we start seeing SMRs being churned out like those proverbial widgets, those economies of scale will kick in and make them much more competitive with other energy sources.
So it's a long game, but the potential payoff could be huge.
Yeah.
Now, I'm curious about the investment landscape. Who's putting money into SMRs? And where are those opportunities for growth that you mentioned?
Well, it's an interesting mix right now. You have those traditional players in the energy sector, utility companies, engineering firms. They're kind of dipping their toes into the SMR waters.
Right. It makes sense that those with like a long history in energy would be interested in exploring these new avenues.
Right. But you're also seeing governments stepping up with research funding and supportive policies. And then there's this whole wave of venture capitalists and private equity firms looking to back these innovative SMR designs and technologies. They're the ones that are willing to take those early stage risks, betting on the future of clean energy.
So it's not just those big players with deep pockets. It's also those nimble and innovative startups driving things forward. I find that really encouraging. It speaks to the real momentum that's building behind SMRs.
It does. It's a dynamic and rapidly evolving landscape.
Okay, so we've talked about the potential, the challenges, the economics. But what about the timeline? When can we realistically expect to see widespread deployment of this technology?
Yeah, that's the million-dollar question. And unfortunately, there's no easy answer. The SMR world is still relatively young with different designs at various stages of development.
So it's not like flipping a switch and suddenly SMRs are popping up everywhere. It's more of a gradual process.
Exactly. Some companies are aiming to have commercial SMRs operational within the next few years, while others have longer timelines. But the important thing is that we're seeing real progress. Demonstration projects are popping up around the world, testing out different designs and gaining valuable operational experience.
It's like watching a field of seedlings start to sprout. It takes time, patience, and the right conditions. What about the regulatory side? Are governments working to adapt their frameworks? to accommodate these smaller, more modular reactors.
Absolutely. The regulatory landscape is evolving as we speak, with countries around the world recognizing the potential of SMRs and working to streamline licensing processes. It's an ongoing process, but there's definitely a sense of urgency and collaboration.
So we're seeing technological advancements and investment pouring in, regulatory frameworks adapting. It sounds like all the pieces are falling into place for SMRs to really take off. But let's talk about the competitive landscape. Our source material mentioned quite a few companies vying for a slice of that SMR pie. So who are some of the key players beyond NuScale, and what makes them stand out?
Well, NuScale is certainly making a splash with their NRC-certified design, but there are many others out there pushing the boundaries. One company to watch is Terrestrial Energy, a Canadian firm that's developing an integral molten salt reactor.
Molten salt. Okay, that sounds pretty sci-fi.
It is quite cutting edge. Molten salt reactors use a liquid fuel instead of those solid fuel rods, which offers some inherent safety advantages. And Terrestrial Energy's IMSR design is garnering a lot of attention for its potential for enhanced efficiency and waste reduction.
That's fascinating. Are there any other companies using this molten salt technology?
Not many focusing on SMRs, but there's another player I think is worth mentioning. X-Energy, an American company. They're developing a high-temperature gas-cooled reactor.
High-temperature gas-cooled reactor. That's a mouthful. What's special about that design?
HTGRs, as they're called. They can operate at much higher temperatures than traditional reactors. This makes them suitable not only for electricity generation, but also for industrial processes like hydrogen production, which we talked about earlier.
Ah, so it's like a multi-purpose reactor.
Yeah.
That can kind of do double duty. It seems like we're seeing this real diversity of designs and approaches in the SMR space. It's like a clean energy race with everyone trying to find that winning formula.
It is. And it's not just those newcomers pushing the envelope. You also have those established nuclear giants like GE, Hitachi Nuclear Energy, and Westinghouse. They're developing their own SMR designs, leveraging their decades of experience in the industry.
So it's a real mix of old and new, big and small, all contributing to this exciting evolution of nuclear technology.
Yeah, that's what makes this field so dynamic and fascinating. There's so much innovation happening, so much potential waiting to be unlocked.
It's like watching the early days of the internet or the smartphone. You know, something big is happening, but you can't quite predict how it's all going to unfold.
Exactly. And that's what makes it so exciting to be a part of this field.
Okay, so we've got this incredible mix of companies' designs and approaches, all vying for a place in the future energy landscape. But with so much at stake, I imagine the competition must be pretty fierce. So what are some of the key things that these companies are focusing on to differentiate themselves?
Yeah, it's all about finding that sweet spot of safety efficiency, cost competitiveness, and market fit. You know, some companies are emphasizing their unique reactor designs, touting those inherent safety features or those higher operating temperatures for specific applications.
So it's not this one-size-fits-all approach. It's about tailoring the designs to meet specific needs. I like that. It seems more thoughtful than just trying to create like a single reactor to rule them all.
Right. Others are focusing on streamlining their manufacturing processes, aiming to deliver SMRs faster and at a lower cost. And some are putting a lot of effort into building those strong partnerships, securing those fuel supply agreements, and navigating the regulatory landscape to ensure a smooth path to market.
It's a multifaceted challenge, that's for sure. It requires not just technical brilliance, but also business savvy and a deep understanding of this complex energy landscape. But from what I'm hearing, there's no shortage of innovation and drive in this field.
You're absolutely right. The level of dedication and ingenuity is truly inspiring. And I think it's this combination of factors, technological breakthroughs, economic viability, and this growing recognition of the need for clean energy that's driving the SMR movement forward.
It feels like we're on the cusp of something truly transformative.
I think we are.
Now, as we wrap up this part of our deep dive, I'm left wondering about those long-term implications that you mentioned earlier. How do you see SMRs shaping the global energy landscape over the next few decades? What kind of world are we moving toward?
That's a great question to ponder. As SMR technology matures and deployment accelerates, we could see a pretty significant shift away from those centralized, large-scale power plants that have dominated the energy landscape for so long.
So instead of relying on like a handful of massive power plants, we could have this network of smaller modular reactors, strategically located closer to where the energy is needed.
That's the idea. And this could have profound implications for energy access, grid resilience, and even geopolitical dynamics. It's a future worth exploring.
I'm completely with you on that. Join us for the final part of our SMR deep dive, where we'll delve deeper into those long-term implications and explore what this all means for you, the listener. Welcome back to the final part of our deep dive into SMRs. It's been quite a journey so far, hasn't it? We've gone over the nuts and bolts of the technology itself, the challenges, the economic opportunities, and even some of those mind-blowing possibilities like desalination and hydrogen production.
Yeah, it has. I think we've only just scratched the surface of what SMRs could really achieve.
I totally agree. Now, in this final part, I kind of want to bring things down to earth a bit and focus on, what does all of this mean for you, the listener? How might the rise of SMRs impact your community, your job, your everyday life?
Yeah, it's easy to get lost in the technical details, but the real power of knowledge is in understanding how it affects our lives. So let's bring it home.
Right, let's get personal. So imagine your town or city is powered by an SMR, providing this clean, reliable electricity. What would that mean for things like air quality, local jobs, your energy bills?
Well, it could be transformative. Cleaner air, more jobs, potentially even lower energy costs as SMRs become more efficient and cost competitive.
It's a pretty compelling vision. And what about for those of us who live in areas that are prone to natural disasters, hurricanes, earthquakes, floods? Could SMRs provide this sense of energy resilience, keeping the lights on when the grid goes down?
Absolutely. That's a key advantage of SMRs. Their smaller size and that modularity. It makes them much easier to deploy in these remote or challenging locations. They could even serve as backup power sources for critical infrastructure like hospitals and emergency shelters, during those times when you need it most.
That's a real game changer, especially for those communities that are on the front lines of climate change. Now let's talk about jobs. The nuclear industry has long been a source of these high-paying skilled jobs. Could SMRs breathe new life into this sector, creating opportunities for like a whole new generation?
Absolutely. And it's not just about those specialized nuclear engineering roles. The development, the construction, the operation of SMRs. It requires a diverse workforce, from welders and electricians to software developers and project managers.
It's like this whole ecosystem of jobs springing up around this technology.
Yeah.
And these jobs are often located in communities that have been hit hard by the decline of those more traditional industries. So it's not just about clean energy, it's about revitalizing those local economies.
Yeah, you're hitting on a really important point. The transition to a clean energy economy, it has to be about more than just technology. It has to be about people, jobs, and opportunity.
Okay, but I know some listeners might be thinking, this all sounds great on like a big picture level, but how does it affect me personally?
Well, think about the products that you use every day. Your smartphone, your clothes, the food you eat. A lot of these things are produced using these energy-intensive processes. And as SMRs help to decarbonize those industries, it could mean a lower carbon footprint for the things that you consume. It's about making more sustainable choices without having to sacrifice your modern lifestyle.
That's a pretty powerful message. It's not just about saving the planet, it's about living better,
Yeah.
more consciously. Now, I want to touch on something that always comes up in discussions about nuclear energy. And that's risk. So what are your thoughts on the potential risks associated with SMRs? And how do those risks compare to other energy sources?
It's important to acknowledge that all energy sources come with risks. Fossil fuels, they contribute to air pollution and climate change. Renewables like wind and solar, they can have environmental impacts. Related to land use and manufacturing, there's no such thing as like a risk-free energy source.
So it's about kind of weighing those pros and cons,
Yeah.
understanding the nature of those risks, and putting those appropriate safeguards in place.
Precisely. When it comes to SMRs, those risks are primarily associated with safety and security. But as we've discussed, SMRs are designed with these multiple layers of safety features, and they undergo this really rigorous regulatory scrutiny. The nuclear industry has a strong track record of learning from past incidents and continuously improving those safety protocols.
And it's also worth noting that the risks associated with SMRs, they're highly localized. So a potential accident would have a much more limited geographical impact compared to, say, like a major oil spill or a widespread power outage.
That's an important point to consider. It's about understanding the scale and scope of those potential risks.
Okay, let's talk about the elephant in the room. Nuclear waste. It's a topic that often elicits strong emotions and concerns. So how do SMRs handle waste? And what are the long-term solutions?
So it's crucial to acknowledge that nuclear waste management, it's a challenge for the entire nuclear industry. However, some advanced SMR designs, they actually have the potential to reduce waste generation or even utilize existing waste as fuel.
So the future of waste management might not be as daunting as some people fear.
There's a lot of research and development happening in this area. Researchers are exploring various options from recycling spent fuel to developing new types of waste containers to exploring those geological disposal methods.
It sounds like there's a real commitment to finding those safe and sustainable solutions.
There is. The nuclear industry understands the importance of responsible waste management, and there's a lot of brilliant minds working on this issue.
Okay, so as we wrap up our deep dive into the world of SMRs, I want to leave our listeners with kind of a call to action. You know, what can we do to learn more about SMRs, engage in these meaningful conversations, and advocate for those policies that support these clean energy technologies?
Well, first and foremost, stay informed. Read articles, listen to insightful discussions like this one, and follow organizations that are working in the clean energy space. Ask questions, challenge assumptions, and don't be afraid to engage in those respectful dialogues. And most importantly, remember that you have a voice. Contact your elected officials, support organizations that are working on these clean energy solutions, and advocate for policies that align with your values.
It's about taking ownership of our energy future and shaping a world where clean, safe, and reliable energy is accessible to all. Well, we've reached the end of our SMR journey. I want to thank you so much for sharing your expertise with us. And to our listeners, we hope this deep dive has empowered you, sparked your curiosity, and inspired you to be a part of this clean energy conversation. Until next time, keep exploring, keep questioning, and keep diving deep.